Rocket, NASA's new moon lander, the mission that could change everything about the moon. This year marks one of the most exciting moments in modern space exploration. A brand new lunar lander, designed and built in the United States, is being prepared for launch, and this time, it's carrying one of the most ambitious payloads ever conceived in America's renewed push to return to the moon. This is NASA's next step toward a permanent human presence on the lunar surface. But it's more than that. This mission could revolutionize how we explore, mine, and live beyond Earth. Today, we're diving deep into NASA's latest commercial lunar payload services mission and the spacecraft leading the charge, Athena, a robotic lander built by Intuitive Machines. Full moon symbol, a new generation of lunar explorers. NASA's Commercial Lunar Payload Services, CLPS, is not just one mission, it's a partnership program. Instead of NASA designing and building every spacecraft, the agency now works with private companies to send scientific instruments and technology to the moon. These landers pave the way for Artemis, NASA's crewed lunar program. They deliver experiments, test new technologies, and scout the best places to land astronauts safely and stay there long term. The Athena lander, built by Intuitive Machines, represents the next chapter of this approach. It follows the company's earlier Odysseus lander, which launched the year before. Odysseus made headlines when it successfully touched down on the moon, marking the first U.S. lunar landing in more than 50 years, but then immediately tipped over after touchdown. Despite that mishap, Odysseus proved that a commercial company could safely deliver payloads to the lunar surface. Now, Athena, named after the Greek goddess of wisdom, aims to do it better, smarter, and more precisely. Satellite hashed the destination, Mons Mouton, the moon's towering South Pole peak. Athena's target is Mons Mouton, one of the tallest mountains near the moon's South Pole. The mountain was named after Melba Roy Mouton, a NASA mathematician and one of the brilliant hidden figures who helped chart spacecraft trajectories in the early days of spaceflight. Mons Mouton stands on the outer rim of the massive South Pole Aitken Basin, one of the largest and oldest impact craters in the solar system. This area has become the focal point of global lunar exploration, not just for NASA, but also for China, India, and Russia. Why? Because in the eternally dark craters and shadowed valleys of the South Pole, scientists believe water ice has been preserved for billions of years. That frozen water could become the single most valuable resource in human space exploration, providing drinking water, breathable oxygen, and even rocket fuel. NASA's canceled Viper rover was originally scheduled to explore this region in detail, drilling beneath the surface to hunt for ice. Now, Athena is carrying on that mission, using many of the same instruments that Viper was meant to deploy. Gear has the lander, stronger, smarter, and more precise. Intuitive Machines has taken everything they learned from the Odysseus mission and improved it dramatically. The company's CEO, Steve Artemis, explained that Athena's Nova Sea lander platform now features upgraded navigation software and stronger landing legs, allowing it to touch down with 20 times greater accuracy than before. That precision will be vital. Mons Mouton slopes are rugged, with steep ridges and unpredictable lighting. Landing even a few hundred meters off target could mean disaster. But Athena isn't going to the moon empty-handed. It's bringing with it a collection of groundbreaking payloads, instruments that will help scientists study the moon's geology, atmosphere, and resources like never before. Nut and bolt the Trident drill, digging for lunar secrets. One of Athena's most exciting instruments is the Trident drill, designed by Honeybee Robotics for NASA. Originally built for the canceled Viper rover, Trident, short for the regolith and ice drill for exploring new terrains, uses a rotary percussive technique, much like a hammer drill, to bore down 1 full meter beneath the lunar surface. This is no simple task. The moon's soil, called regolith, is sharp, jagged, and behaves almost like dry cement. As the drill bites into the ground, it collects tiny samples of lunar dust and rock, called cuttings. These samples are then fed into a small but powerful mass spectrometer called M-SOLO. M-SOLO will analyze the chemical composition of these samples, searching for traces of water, carbon compounds, and rare minerals. Each discovery can help scientists understand the moon's history and prepare for extracting useful materials in future missions. Robot faced the mini rover, the Map Explorer. Athena will also deploy a small rover known as MAP, Mobile Autonomous Prospecting Rover, built by Lunar Outpost, a company known for its innovative robotic explorers. This tiny vehicle, standing less than 2 feet tall and weighing under 10 kilograms, is equipped with 4 rugged wheels, a depth-sensing camera, and a suite of environmental sensors. Despite its small size, MAP is capable of creating high-resolution 3D maps of the lunar terrain. The images it collects will help scientists construct realistic virtual reality simulations of the moon, the same kind astronauts will use for training before setting foot on its surface during future Artemis missions. And one of those Artemis landing zones? You guessed it, Mons Mouton. So, MAP isn't just a scientific rover, it's also helping pave the way for humanity's return to the moon. The AstroAnt rover, small but smart. Riding alongside MAP will be a tiny experimental rover from MIT, affectionately named AstroAnt. About the size of your hand, AstroAnts are designed to operate in swarms, groups of tiny machines that can work together to explore large areas or perform complex tasks in coordination. These rovers use magnetic wheels that allow them to cling to metallic surfaces and climb small slopes. On this mission, the AstroAnt will crawl across the MAP rover's back, testing how thermal systems behave in the harsh lunar environment. By monitoring temperature fluctuations across MAP's radiator panels, AstroAnt will help engineers design better, more efficient systems for keeping future lunar vehicles from overheating or freezing in the moon's extreme conditions. Satellite Micronova, the rocket-powered mini-hopper. Now, perhaps the most futuristic part of the mission, the Micronova hopper. Think of it as a tiny spacecraft within a spacecraft, a cube-shaped mini-lander only 2.5 feet across, equipped with its own rocket engine and landing gear. Micronova can hop from one lunar site to another, carrying up to 1 kilogram of scientific payload over distances of nearly 2.5 kilometers. In a single mission, it can make up to 5 hops, allowing it to reach places that are too dangerous or inaccessible for a lander or rover, like the deep, permanently shadowed craters of the lunar South Pole. These are the places where water ice is most likely hiding, frozen solid for billions of years. Micronova will fly into these craters, capturing high-resolution images and using onboard instruments to detect hydrogen, a strong indicator of water, beneath the surface. If it succeeds, it could become the first vehicle in history to explore lunar lava tubes, natural tunnels beneath the moon's crust that may one day become habitats for astronauts. Satellite dish communication, 4G on the moon, all of Athena's systems, from the lander itself to the rover and the hopper, will stay connected using a Nokia 4G LTE communications network. Yes, you heard that right. There will be cell service on the moon, at least a small-scale experimental version of it. This network will allow the rovers and hoppers to send real-time data, images, and video back to the Athena lander, which will then beam everything home to Earth. It's an incredible step toward creating a permanent communication infrastructure on the moon, something future astronauts will rely on heavily. Milky Way beyond the moon, the SPAGX mission. While Athena explores the lunar surface, NASA will also be looking outward, way outward. Launching soon after Athena, NASA's SPAGX telescope, spectrophotometer for the history of the universe, epoch of reionization, and ICE's Explorer, will scan the entire sky to map hundreds of millions of galaxies and detect the frozen building blocks of life, like water and organic molecules, throughout the Milky Way. Together, Athena and SPAGX represent NASA's dual vision. Explore the nearest world to us in unprecedented detail, and study the farthest reaches of the universe at the same time. Shooting star of the future, mining, living, and thriving on the moon. The success of Athena could have enormous implications. If it can confirm the presence of accessible water and prove that small, modular robotic systems like MAP and Micronova can operate reliably, it would set the stage for lunar mining operations, and eventually, human habitats. Future missions may use the data from Athena to design bases that extract oxygen and hydrogen from lunar ice, generating fuel for deep space travel, turning the moon into a launch pad to Mars and beyond. The bigger picture. In less than a decade, we've gone from talking about returning to the moon to actually building the technology to stay there. Athena's mission, though robotic, represents the first steps in a new lunar civilization, a network of intelligent machines, drilling, hopping, scanning, and mapping, all so that humans can one day call another world home. And as NASA, SpaceX and other private partners continue to push the frontier. One thing is clear. The next giant leap isn't just about getting to the moon again. It's about learning to live there,